Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from QLogic. We have Joe Yaworski. Joe is Director of Product and Solution Marketing for high-performance computing. Welcome to the show, Joe.
Hi, Rich. Thank you for having me. QLogic is going to be doing two announcements. One around its award by the Department of Energy for an award called the TriLabs Linux Capacity Cluster. And then the second is around our release of the InfiniBand Fabric Suite 7.0 or a 7th generation release. So let me go through the TriLabs award with you. And so if you can go to slide 2. QLogic was awarded by the Department of Energy a very significant award. It's approximately 20,000 nodes, 320,000 cores, and it is for clusters that'll be installed at 3 of the major DOE labs. So Lawrence Livermore, Los Alamos, and Sandia National Lab. Essentially what these clusters, or why the labs decided to come out with this type of an award of this size and magnitude, was so that they could standardize on clusters and so forth over the next 3 years. And essentially then they could leverage the volumes of the 3 labs into a single award and thereby getting better prices. Essentially the clusters will be used for the computing capacity for these labs for doing everything from national nuclear deterrent, also to be also used for other classified and non-classified applications. And essentially the total award, when it's fully deployed, will be about 3 petaflops of performance. And the key technologies involved in this award are APRO's Extreme X blades, Intel's next generation processors, the Xeon codenamed Sandy Bridge processors, and QLogic TrueScale QDR InfiniBand. The interesting part about this is this award was a competitive offering. APRO had actually bid 3 different interconnects, one being TrueScale, QDR InfiniBand, the other being the next 2 generations of Mellanox FDR technology. And so the labs actually had APRO set up a benchmarking cluster with each of the interconnects so that they could try them out and see what kind of performance and so forth. And QLogic, with its current generation of InfiniBand, was deemed to be the best interconnect for this award for the TriLabs. So a very nice endorsement of the overall architecture and potential of the TrueScale QDR InfiniBand. Slide 3. Now, this is a follow-on to QLogic's award last year at Lawrence Livermore National Labs. And Lawrence Livermore National Labs acquired 4,000 nodes from Dell, and those were interconnected by QLogic TrueScale InfiniBand. And it went so well that Matt Leiniger, the Deputy for Advanced Technology and Projects, who was responsible for this acquisition and deployment, actually presented at the QLogic booth at Supercomputing 10. And essentially what he saw are the performance that they saw, if you move to slide 4, showed that the TrueScale Dell cluster, codenamed Sierra, was by far one of the best clusters that they ever deployed in terms of performance and scalability. Essentially, this chart shows the performance of clusters over time, and the chart shows the lower the better, and essentially a perfect scalability would be a line that runs right along the x-axis. The line at the bottom that's an orange type line is actually the Sierra cluster. It was approximately 2,000 nodes, 24,000 cores, and shows very good scaling and performance. In fact, far better than any other cluster that they had ever deployed, even though some of those clusters that they had deployed in the past were based on proprietary interconnects. The Sierra cluster, with its TrueScale QDR InfiniBand, actually showed very good scaling and performance. And if you move on to slide 5, this was Matt's summary chart in which he says basically the scalability of the IB fabric, in this case it was QLogic's TrueScale InfiniBand, was the best in class. And the reason why is it showed excellent latency on a 2,000 node fabric of 1 to 2 microseconds, very high message rate, specifically MPI message rate, as well as excellent MPI collectives performance. And so when we look at this deployment that we did and the success we have, we feel that that set the foundation and formed a reputation within the labs that resulted in this award, this recent award, this TLCC2 for Trilabs Linux computing capacity clusters. And so it bodes well for TrueScale InfiniBand. Our current generation obviously fared well against Mellanox's next FDR generation. And as we move forward and come out with our next generation, actually, which will perform even better than our current one, it looks like we'll fare pretty well against our friendly competition in the marketplace at that point in time. So that'll be the first announcement that'll be going out. The second announcement is around our InfiniBand Fabric Suite 7.0. So it is our 7th generation. And if you move on to slide 6, I'm going to take you through that. And now let's move on to slide 7. Actually, if we can, let's move to slide 8. So the QLogic InfiniBand Fabric Suite, or IFS for short, let me just set the stage as to exactly what that is. It is a comprehensive fabric management tool set. And essentially, it covers the installation, the verification once a cluster is installed that it is operational, all the links are performing at the right level, all of the servers in the fabric are actually performing at the expected performance level, as well as ongoing management of that cluster. So things like diagnosing a problem, updating firmware, and so forth are all included in the tool set. As well as there are a number of advanced features within IFS for fabric optimization. They include things like our virtual fabric, or vFabrics, which allows for the partitioning of the cluster and even setting up partitions with certain quality of service levels. It includes congestion detection and hardware-based adaptive routing. So a number of features that optimize the performance of the cluster. So now as we move forward with IFS 7.0, which again is our 7th generation, some of the key things that have been added are the Fabric Viewer. It now, we've always had a GUI-based Fabric Viewer, but now there is a dashboard that gives a real-time view of the performance of the fabric. And then we have done a number of value-add integrations with third-party products. The first is with platforms, HPC cluster management products. And there, if you think about it, platforms managing the overall cluster, QLogic is managing the fabric. We've now brought them together where actually from one toolkit, that being the platform cluster or console manager, you can actually access the fabric management and perform the cluster management simultaneously. We've also done a cross-integration with both adaptive and platforms job scheduling, and that's essentially to integrate those with our vFabric quality of service capabilities. We then have done in the past, we've had an integration with NVIDIA's GPUDirect, We've now made that easier to obtain the code by including it now in IFS 7. And then there's been some significant file system performance enhancements that I'll go through. So moving to slide 9, as I said, the Fabric Viewer has now been updated with a dashboard view of the Fabric. And essentially it gives a view of the bandwidth, congestion that might be occurring, packet rate, various other metrics of information. And slide 10 actually shows the real-time view of a Fabric running. And as an example, in the upper left graph shows the bandwidth that's being used over time. In the center, it shows that there at a point there was congestion forming on one of the inner switch links that would allow then a user to say, okay, maybe I should be turning on the congestion detection and adaptive routing features that are automatic and would adjust in real time for those. So that's now been included. And moving forward from there to slide 11, some of the other improvements have been to improve a lot of the tools for doing the deployment and verification and optimization. So there have been tools that have been added to optimize getting a Fabric up and running, as well as tools and capabilities have been added to handle things like better multicast algorithms and so forth. Some of the other things that have been added is real-time detection or the ability to detect and even disable links that might not be performing well as you're doing an install, but being able to disable them and move on so you can complete the installation efficiently and so forth. Moving on to slide 13, we have always integrated with platform and cluster corp kits and ROX roles, as well as the open source ROX roles. But what I'd like to point out here is that we have used the relationship, especially with platform, to do some additional integration. And as I said, if we move on to slide 14, that we have actually worked with platform to work with the platform cluster manager, and specifically with the console portion of that, where platform from its console can actually call the IFS fabric management tools. So when you're giving one interface to a user that allows them to manage the cluster overall, as well as the fabric, all from a single tool set. So a very nice addition and integration that should ease the management of both the cluster and the fabric going forward for those that are using platforms tools. Now, the other thing that we have done is we have integrated with LSF and with MOAB into our vFabric's quality of service capability. So as a job is coming in and being scheduled into the fabric, it will automatically be placed into the right quality of service partition. You can have up to 8 of them. And it allows for basically jobs to be scheduled into a partition that provides the optimal resources for it, such as bandwidth and other resources. So important jobs get scheduled into those that will give them the highest priority for various resources. Other jobs that are of lower priority will get it scheduled accordingly. So when you think about it, something like that allows for a fabric that's being used by multiple users and multiple jobs simultaneously, a means now of optimizing how those jobs are placed and the resources that they will get through this joint integration between LSF and MOAB with QLogic's vFabric's quality of service capabilities. Moving on from there to slide 15, we have we released a while ago the ability to work with NVIDIA GPUs through GPUDirect. Now, both for us and for other InfiniBand providers out there, there needs to be an update done to support GPUDirect. And to fill in exactly what GPUDirect does is without it, there are memory pinning issues that cause basically contention for the same memory. And with that in mind, GPUDirect allows for an efficient means of handling that so that all you are is doing a single copy and then a write out to the InfiniBand adapter. So removing multiple memory copies that were required before. Now, in the past, to get the updates from us and from, as an example, Mellanox, required that you made a special request to each of our companies, and then we would send out a package or we would distribute to you the update that was required to make GPUDirect work. We have now made it easier by including that into IFS 7.0, so it's automatically there. And then another important point is that QLogic's approach with NVIDIA to GPUDirect is that it is a minor update that does not require a Linux kernel update like other GPUDirect updates do. So what that means is that since we're not requiring a update to the Linux kernel, it's easier to install, as well as you do not get into any potential support issues with other third-party packages because you're running on a modified kernel. So it's an easier, more streamlined approach to install, and now we made it easier to acquire because it's included right in the IFS release. Slide 16. We have, these are the releases of Red Hat and Novell that are now supported with IFS 7. And so these keep us fresh and up to date across, the major Linux distributions and so forth. So if we go to slide 17, let me just quickly summarize. QLogic's InfiniBand Fabric Suite, we're now on the 7th generation. It provides a easy-to-use way of installing, verifying, and managing fabrics. It includes quite a few fabric optimization features that provide for optimized performance. And then over and above that, we have done some value-added integration with platform, adaptive, as well as NVIDIA to make it a more effective offering in environments where you're running where you have a cluster that's being used by multiple users or running multiple jobs simultaneously, or you have a GPU-based cluster. Okay, thank you very much, Rich.
Well, thanks for that, Joe. A couple questions here.
Sure.
As far as these tri-lab deployments, I would imagine, how far off are they, or does it vary by which lab it is and what their budget? How's that going to work?
So we will start installations in, I believe, the August timeframe.
Okay.
So it's going to be real soon. And the first set of clusters go into each of the labs in that August, September timeframe. Mm-hmm. And then the clusters additional clusters will be installed over time, going out for 18 to 24 months from now.
Okay. So I was going to ask you the question about QDR. Would these initial ones probably be at the QDR level of performance, then possibly moving on to the FDR? Are you guys talking about that?
I think what'll end up happening with these deployments, because of the approach that the labs take with something called scalable units. So essentially they put together, I believe, 154 nodes into a single kind of sub-cluster that they then have the ability to interconnect together to form very large clusters. So they will probably stick for this deployment with the TrueScale QDR just to keep compatibility and interoperability.
I see. So then the other thing I wanted to ask you about is this this automation. It looks like you're integrating with Moab on the one side and Platform on the other. Is it like an API? I mean, is it easy for these system management vendors to plug into this? How does that work?
Yeah, essentially what we've done is we put together a series of a little bit more complex than scripts, but think of them as scripts that a user can run, integrate things together, and then gives them the ability as they're scheduling their job to identify which of the vFabric quality of service partitions that job should be placed into. We've also discussed with both partners looking at even more sophisticated scheduling of jobs that we'll be rolling out over the next several releases that would allow for things like being able to take a look at where in the fabric, given these jobs should be placed, given the nodes that they need to communicate, so that we can reduce switch hops, as an example. So putting jobs into a neighborhood of nodes that are closely connected, so thereby eliminating latency due to excessive switch hops.
Mm-hmm. Well, Joe, this sounds really good. Are you coming out to ISC next week?
Unfortunately not. I have to go in another direction. We have an excellent team there.
Yeah.
But I'm going to be traveling to the other part, to almost directly in the opposite direction to another part of the world.
Okay. Well, we'll come by the booth and see what you guys are up to in Hamburg for sure. That's it for the Rich Report. Stay tuned for more news and information on high-performance computing.